about authoring narrative videos, and in this talk I'm going to talk about an interface to author the narrations, or speech recordings. So as we saw, narrations are used in various occasions. We also need them to make submission videos for UIST, or not videos, but for radios or podcasts. Authoring speech recordings involves several tasks. First, you start with some kind of a script, and then you make recordings based on the script. And then you will edit these recordings to make the final track. Most of the time, this is not a straightforward linear process. Sometimes you have to edit the script after recording the audio, or you realize that some sections are missing after editing the audio. The point is that there's a lot of going back and forth between these tasks. Unfortunately, current tools don't facilitate this going back and forth process. Actually, many of the tools that we use completely separate the script from the audio. So typically, users would write the script in a word processor and then use a different application to record and edit the audio. This separation between the script and the audio makes it difficult to iterate back and forth. One of the major problems is that the script and the audio recordings become out of sync. For example, even when there's a fairly detailed script, it's very common for narrators to adjust the sentences or improvise. Here the script says, "There were many wars and fierce battles," but in the recording session, the narrator can read, "Wars and fierce battles continued on for ages." When this happens, the script and the audio are no longer in sync. Another very common scenario could be, for instance, making a video for UIST. Your script might be a simple outline of bullet points. So here I said users iterate back and forth. That's written in the script. But when I was doing the recording, I elaborated and said, typically people iterate back and forth between the script and the audio. You might not even have a script at all. So now some amount of improvisation is necessary, and the discrepancy between the script and the audio will be bigger. Now, if you or your advisor wants to make refined edits to the wording of the audio, it's not very straightforward. The editor has to scrub carefully through the audio to know what's recorded, mark the place either by its timing or by transcribing the audio, and then add the edits. And this process of scrubbing through the waveform is very tedious, as Ann mentioned. As you can imagine, these tasks are even more tedious when you have multiple recordings or multiple people involved in creating the audio. To remedy these problems and bridge the gap between script and audio, we designed a novel interface called VoiceScript. And VoiceScript integrates scripting, audio recording, and audio editing in a single unified interface. To design VoiceScript, we relied on 3 key ideas. First, we use automatic speech recognition to transcribe speech to text. And as you will see in the talks in this session, and also in previous work, people have explored this idea of text-based navigation for audio. And they've also shown through various user studies that text is an effective way to represent speech recordings. Once we transcribe the speech, now we have text as the common form of representation, both for the script that you wrote and for the audio recordings. Now, our idea is, instead of having separate representations for the script and the audio recordings, we will combine them in a single document. We call this document the master script in our interface. The master script will be linked to the audio, which represents the final track that you're authoring. It'll include recorded speech that's from the audio transcripts, but also unrecorded text that you wrote in the script. It'll also keep track of any text edits to the recorded text. So instead of keeping track of script edits and audio recordings separately, both editing the script or recording the audio is treated as updates to the same master script. Edits to the text is linked to the corresponding audio, and recording audio will update the master script text. The master script becomes essentially a representation that keeps track of the current status of the project. So remember, we began with a script, and then we obtained the transcriptions from the audio recordings. But to get this unified master script, we need to somehow merge in the audio transcripts into the script. We approached the problem of merging the audio transcripts and syncing them with the master script as a text differencing and merging problem. To do that, we need to be able to compare the script with the master script and see which parts correspond and which don't. Our tool segments and aligns the master script with the audio transcript. We visualize parts of the recording that is improvised, that's in green, and parts of the script that's not been recorded in the audio yet. To create the final track, users can accept audio segments from the transcript, and this will overwrite the corresponding section in the master script and also update the final track audio. To clarify these ideas, let me go ahead and demonstrate our interface. So on the left side, you see the script that I wrote to record. And on the right side, I went ahead and recorded 3 different takes based on these scripts. And you're looking at the transcriptions of the audio recordings that I made, which we obtained from speech to text. So each take is associated.
Speech recordings are central to modern communications, such as podcasts, voiceover.
Now, what's not clear is in this view is the relationship between the script and the audio transcripts. But the idea is you want to mix and match the 3 takes to create the final track. If I turn on the alignment view, now we automatically compute a match between the sections of the script and sections of the audio transcript. And even if they are not, even if the script is just a bullet point outline, it will match corresponding sections of the audio transcript. Here we also visualize parts of the audio transcript that was not in the original script, but that was improvised in take 1, and also parts of the script that was not recorded in take 1. And likewise for take 2 and 3. In the All tab, when you have multiple recordings, we group the alternative takes of the same sentence. And you can choose between the alternative takes. So let me go ahead and accept them. When I accept the segment, it overwrites corresponding sections of the script and also updates the master script audio. So I'm going to accept all of these takes. And then you see that this section has not been recorded in any of the takes. So let me go ahead and try to record that. Is the internet on? We take advantage of automatic speech recognition to transcribe speech into text. We're using an off-the-shelf IBM speech-to-text service to make the transcription. Once the transcription comes out, it is automatically aligned to the right portion of the script, so I can go ahead and accept it. And then let me listen to part of the...
The main problem is that these applications treat the written script and the recorded audio as completely separate entities.
We take advantage of automatic speech recognition to transcribe speech into text.
Our interface integrates.
So you noticed how it took out the silent gaps and merged between different takes. Let me go back to the presentation. So here are 3 key components of our system. First, we have the audio transcript obtained from speech recognition. And secondly, we support text-based editing in the master script. When we obtain the transcription, each word comes with a timestamp, so edits to the recorded text can be propagated to the associated audio. And finally, to support merging, we align the segments from both texts. This part is the main technical component in our system. So I'm going to spend a few next minutes to elaborate on this part. The main challenge of this task is the fact that the audio transcripts and the master scripts won't match exactly. As we saw earlier, it's common for the script to be incomplete or the narrators to improvise, and we want the alignment and segmentation to take this into account. So as a first step, we compute a per word alignment between the 2 texts. On the top, you see the master script text, and the bottom is the audio transcript. We use the Needleman-Wunsch algorithm to compute word-per-word match. And for each word in one of the texts, it'll compute a match for an output for at most one matching word. It can account for words that don't exactly match and also for gaps. We use this per-word match results to segment the text. We want to segment both the master script and the audio transcript. So we use an alternating approach where we'll start with an initial segmentation, Those are the vertical bars are the segment boundaries. And then we will segment the master script, and we will use this segmentation result to segment the audio transcript. And we will alternate this until we reach convergence. To segment each text, we use a variant of the classical line breaking algorithm. And this algorithm requires a scoring function that tells how good a candidate segmentation is. So let me elaborate on this scoring function. For our purpose, there's 3 different conditions that make a good segment. First of all, we prefer boundaries that are natural in speech. So we consider all boundaries between words as candidate boundaries, and for unrecorded text, the preferred boundaries will be where the commas or periods or punctuations are. In case of recorded text, we prefer boundaries to be where there are longer pauses between the speech. The numbers below indicate the seconds of silence between the words, and the preferred boundaries are where there are longer silences. Secondly, we compare the master script to the audio, and we want to know which parts are recorded and which parts are still missing so that I have to record in the next sessions. So we want to separate unrecorded parts from recorded parts. Also, when we are merging in the script to the master script, it will be useful to know if some parts were improvised versus parts that were planned in the script. If we look at this from the perspective of the per word match that we computed previously, it means that we want to separate words that have a match from the words that don't have a match. So the preferred boundaries in this case will be in these locations. Finally, the end goal we want to achieve is to align the segments from both texts. So we want the segments from each text to be consistent with each other. For instance, in this example, if we don't consider consistency, we'll prefer segments at natural boundaries like this. But if we do that, what is 2 different segments in the master script is a single segment in the audio transcript. And since we don't have a one-to-one match, when we want to merge the audio transcript into the master script, it's not certain which part of the master script to replace. So by preferring consistent segmentation, we can either remove one of the segment boundaries from the master script or add a segment boundary to the audio transcript. Which one of these alternatives we take is determined by how much importance we put on the punctuation versus the silent gaps. The final scoring function is a weighted sum of these 3 terms, but we want to avoid a trivial solution of separating each word into a separate segment. That's what the per word match and the consistency term encourages. So we add a normalization term. Once we have the segment of the 2 texts, we match these segments, and naturally segments that have a higher proportion of matching words will align with each other. Now, finding corresponding sections of the script and the audio is trivial, even when the script and the audio don't match exactly. And also, it's easy to identify parts of the audio that's improvised and parts of the script that's missing from the script. When there are multiple recordings, we align each of them with the master script, so it's easy to look at alternative takes of the same sentence. Here on the right, the first take reads, "Authoring speech recordings involves going back and forth between the script and the audio." And the second take reads, "When authoring speech recordings, we go back and forth between the script and the audio." They're both matched to the script outline that says authoring requires going back and forth. We conducted 2 different types of studies for evaluation. First was to test the overall usability of VoiceScript, and the second one was a comparative study to compare our interface with a state-of-the-art audio editing tool. For the remainder of the talk, I'm going to focus on the first study and highlight some of the important findings, but please refer to the paper for the rest of the details. So our goal was to assess the overall usability of our interface and observe how users leverage various interface features. Participants were asked to create a short audio recording about a technical subject using VoiceScript. We gave them a brief tutorial on our interface and gave them an article, and then they created a short recording explaining the article. In the authoring process, they were allowed to refer to the article at any point in time, but they were discouraged from recording just by reading it out loud. This was to encourage them to go through their own scripting process. The most important observation from this study was how users went through a very wide range of workflow and how VoiceScript was able to support them. For instance, in scripting, some users only wrote a rough outline of bullet points, whereas others wrote a detailed script. One user did not write a script at all, but improvised the first recording and then used the transcription as the first script that was refined throughout later sessions of the recording. During recording, some users recorded a portion of the script at a time, while others preferred to record the entire script at each take. Finally, for editing, some users recorded all of the takes and then edited them together into the final track, while others went back and forth between recording and editing. And VoiceScript was flexible enough to accommodate all of these scenarios. Because the script and the audio is linked, it's very natural to go back and forth between different types of operations. Here are some more highlights from the user feedback. All users offer strong feedback about our authoring interface, especially the master script and the alignment feature. The master script served two purposes. One was it served as a rough outline as well as a detailed script or a transcript of the final track. And users were most enthusiastic about the integration of the script with the audio. They also mentioned that the alignment view helped keep track of the current status of the project, which parts of the script was already recorded and which parts were missing. They mentioned that the text-based merging interface made it easy to cut and merge multiple tracks. I want to point out some limitations and rooms for extension. Our system relies heavily on having a good result for speech-to-text transcription. Transcription errors will affect the efficiency of the workflow. And like we saw, multiple people can collaborate on our interface, but it's limited to asynchronous collaboration at this point. Also, our system focuses on the content of the audio, but there are previous work that focus more on fine-tune editing of the audio quality. For example, to make the cuts between different takes more smooth or to sound similar. And this can be used together with our system. So to summarize, we introduced VoiceScript, a novel interface for integrating scripting, audio recording, and audio editing. We proposed a master script document that unifies the script and the audio transcripts. By closely linking script to audio, we can support a variety of workflows, including iterative and asynchronous collaboration. Thank you.
Any questions from the audience? So, great talk. I have a question. Is this available publicly? It feels like you are making audio editing as flexible as text editing.
It is available on my website.
Okay, that's great. And in the paper, you also mentioned about integrating background music or sound. What are the challenges of integrating that? Because you don't have a corresponding narration for that.
Right. So right now, I think for audio that is not speech, since it cannot be represented in text, it would still be a waveform, or you will have to come up with a different representation that's easier to navigate.
Okay. Any other questions from the audience? We have time for one more question.
Hi, Seok-Hyung from KAIS. I'm wondering if isn't necessary to have a timeline at all?
Pardon?
Timeline is necessary at all?
To have time-aligned transcripts. It is useful when you do edits to the text and want to propagate it to the audio. So for example, I didn't show it on the demo, but if you delete parts of the recorded text, it'll delete that part from the audio. Or if you have parts that you want to add, it will mark it in red to signal, okay, this part you've modified after recording, so you have to re-record it.
Okay, so one more thing. Since you have seen her awesome work and talk, Valentina is graduating next year, and if you have any research positions or